Okay. Hi, Chang and Stephen. How are you?
Fine.
We'll get started, okay? We won't wait for people. I will actually get started, and then in the middle, I may call out for some student who's still missing, okay? So today we will continue to look at this chapter 7, the search of solution space, okay? So programming solution space is very important. Let me review it, okay? Let me review it. So last time we actually talked about the optimization problem of a single function that is going to be from 0 to 10. And then you try to find the minimum of the x minus 4, right? We talk about this. So your solution space is where you search for the answer is from 0 to 10. This is the whole solution space you have. And this one is a linear function here, a linear function here. So it's a sectional or what's that say? Piecewise linear function. Okay, you can cut it in half, two linear function, and you can solve the solution. So it's basically a linear function and then one variable. So it's similar to finding the solution in ax plus b equals y, since even though there are two equations, but it's similar to this. So there's one variable you look for and one parameter you look for different a and b that you are looking for the solution. So you search through the solution space, you may find an answer, okay? But we say linear programming, you may not need to search for the whole space. You may just need to search for the corner and bend points. Okay, these are something that you can look at. So when your problem get harder and harder, so let's assume that you actually go into a pattern recognition problem, and then you may have multiple variables. So the multiple variable may divide the solution space into two space, and that has a line, very line, and you may have the AS plus BY plus CZ plus a lot of things. So this one, each one of these, we talk about it as a token, a variable, a token. So when you are optimizing in the multi-variable solution space, the dimension is huge, and you have a larger solution space you need to search for. And AI is supposed to travel through this different solution space to find a good characterization solution. Maybe you are here, so you pass or you fail, okay, to determine that in the solution space. But AI doesn't give you the 100% solution. Sometimes it's blurred on the line. Sometimes the decision is wrong. Sometimes you actually, based on your past experience, you get the wrong answer. So the AI actually searching for approximate solution. It's not really exact solution. AI most of the time, you can call it 95% correct, 85% correctness. So it's a approximate solution, but you go through the whole solution space to search for it. And we learn algorithms. Some of the algorithm we search for the exact solution. It will be exact optimal. Okay, but AI sometimes doesn't search for the exact solution, but because their solution space is so huge, to find the exact solution is so hard. So sometimes the approximate solution may be okay to as a good example. Okay, as a good example. So you may use that. But nowadays, this AI becomes so popular, and then number of tokens keep growing. So most recent one, let's look at the most recent one is the XAI's the Grok 5 has trillions tokens. 5 trillion tokens, trillions tokens. So XAI's growth 5 already over a trillion number of tokens. So the computation is really huge. Okay, it says that it's 6 trillion parameters. Okay. And then recent the so-called AMD MI 500 is talking about the Yoda blocks. So you say that you actually need Yoda block. Yoda is bigger than Terra. Okay, let's look at Yoda. Yoda actually is a bigger scale than trillion. So what is Yoda? Yoda is 10 to the power 24. Okay. This many floating point operation per second. That's a lot of computing power. Okay. So in AI, no matter it's AI or not AI, we learn computer science. We basically need to go through the solution space. And the solution space is related to the number of tokens, number of operations per second. These are all very important, even though AI may solve some problem, but the fundamental things about computer science has never changed. It's just the scale change. The problem get bigger, the solution get more complicated, and then the computing power get more, and you're solving different kind of problem because you have more computing power. But it still searches through a different kind of solution space, and the solution space get bigger, bigger, and bigger. Now we start to hear Yoda. Okay, Yoda's flows. In the past, it's actually terabyte. Okay, teraflow. Now it's Yoda, 10 to the power 24. Okay, so we are entering a new stage of computing. But now let's go back to what we are talking about right here. We are going to teach you what is complete search. So complete search means that you have a solution space. Instead of knowing that you just need to check at the boundary, sometimes you need to go through every single possible point in order to find the optimal. So that actually is a complete search. So last time we talked about subset, how to generate the subset. Okay. The different subset, given we have a set with A, B, C, all of the subset that possible is A, B, C, A, B, B, C, A, C, A, B, C, and empty set. So totally they will be 2 to the power 3. So A will be in or out, B will be in or out, C will be in or out. So the total solution space would be 2 to the power 3. Okay. And remember that actually there's a coding that problem we actually I do with coding bread problem. There's a coding bread problem on the incursion 2. The first one, the group sum. So this group sum problem is said that you have 3 number and sum up to 10. So basically you have 2 that can be in or out. 4 can be in or out. And then A will be in or out. So totally they are 2 to the power 3 solution, and you need to find one. If there's one that actually sum up to 10, then you return the answer. So this is a recursive version. It's going through, searches through all of the possible 2 to the power 3 different solutions in the solution space. And it's by recursion. Okay, so sometimes your search of recursion is by recursion. Sometimes you search for the solution space by for loop. Okay, for example, the one that we talk about, this one from 0 to 10, it actually you can do for x equals 0, x less than equals 10, and then x plus equals 0.001. So let's assume that you don't really search for every point, but you actually find enough. So this will go through every point in the solution, and you can keep smaller scales. The jump scale you can take it smaller, then you will find more point. Okay, but anyway, those are iterative solution, and you can also use a recursive solution to find the solution space. Okay, so the solution space, there are different way to go through the different solution space, and last time we use a for loop to generate a subset. Okay. In principle, it's also possible you can also do recursion to create a subset, just like this good sum problem. Okay. Is that okay so far?
Yeah.
Harrison, you hear me?
Yeah.
But Jiang, do you hear me?
Yeah.
Okay, that's the subset. Today we are going to move on to the combinations. Okay. Combinations is not the full set. Okay, combination, we talk about it in chapter maybe 18 or something, where I forget it. Okay. But today we are going to go into more detailed discussion of the combinations. So first thing we still would talk about the K-graph problem, complete graph. Complete graph, you actually have 2 points A and B, and if you pick two of these number from these two, it can only be A, B. So there's only one edge. Okay, only one edge, A and B. If you have three symbol, you pick two up from them, you will have AB, AC, and BC. So there are three different combinations. If you have A, B, C, D, then you end up with AB, AC, AD, BC, BD, CD. So they are C4, P3. P2, I'm sorry, P2. So keep doing that. This we call it complete graph. Complete graph means that all of the possible combination of two can be picked. Okay, so this one, if you look at the two-dimensional matrix, you have A, B, C versus A, B, C. This is I, this is J. Okay, you iterate through this and this. So as you can see, this one, the diagonal term AABBCC is not picked two, this actually out. Okay, so you will pick two right here, you have AB, AC, and BC. So this actually upper triangle, we talked about it before, the upper triangle will be the combinations. Or you look at the lower triangles, that's actually BA, CA, and the CB. So these two sets, blue set and orange set, either one of them is a K-graph combinations. Okay, so this each one of these is a C3 pick 2. So C3 pick 2, you end up with three possible combinations. It's this one. Okay. And you can use the upper triangle or lower triangle. So this one is a A to B, A to C. The difference between the orange one and blue one is the orange one is in alphabetical order, and the blue one is in reverse alphabetical order, but each one of them is okay. So you have a 2 by 2, you have 3 by 3 matrix. Diagonal one is not in the combination. Upper triangle and lower triangle, each half is a combination. You just need to use one of them. You should be able to solve the problem. So basically, if your number grow up, you have more combinations. So let's assume that you have A, B, C, D, you have 4. Okay, then your upper triangle will be 1, 3, 2, 1. So basically this one, as you can see, is actually C4 pick 3. It is 3 plus 2 plus 1. It is 3 plus 1 times 3 divided by 2. So this one is actually n band divided by n minus 2 band divided by 2 band. Okay, that's the C4P2. And that would be the sum of 1 to n minus 1. Exactly the same, okay? Any questions so far?
No.
Okay, this is a complete graph. Let's talk about another things, the Pascal triangle. Okay, Pascal triangle. This is a complete graph. So you end up with this, let's look at this, let's put it over here. You have A, B, C, A, B, C, okay. So this is the AA, BB, CC, AB, AC, BC, okay? So this is complete graph over here. Now, you say you have 3 variable. So 3 variable can be 0 or 1. And 0 or 1, you have A, B, C. So 0 means A is in. 1 means A is out. I'm sorry. 0 means A is out. 1 means A is in. So this one can be 0 or 1. This one can be 0 or 1. This one can be 0 or 1. So totally the subset, you end up to be 2 to the power 3 that we talked about it already. Now, you break down this 0, 1 to the power of 3. Okay, then you will become, you actually expand it, you will be 1. Okay, so here you have 1. If you have single 1, you can be in or just in, okay, or out. Okay, that's the same that you have just out. If you have 0, 1, you have just out. And then if you have 0 and 1 raised to the power 1, you can be in or out. If you have 2 variable, you have 0, 0, or 0, 1, or 1, 0, or 1, 1. So this one, 1 in, this is 2 in, this is 0 in. Okay, keep doing that, you will end up with 0, and then 0, 1, and then 0, 0, 0, 1, 1, 0, and then 1, 1, and then keep doing that. You keep doing that, you would end up with 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, and then 0, 1, 1, 1, 0, 1, 1, 1, 0, and this one 1, 1, 1. So this one is C3 pick 0, C3 pick 1, C3 pick 2, C3 pick 3. Okay. So you have x plus 1 raised to the power 3. This one will be equal to C3 pick 3 times x cubed plus C3 pick 2 times x squared plus C3 pick 1 times x plus C3 pick 0 times 1. Let me rewrite it. This one not good. So as you can see, this is what we call it binomial theorem. And then C3 pick 2 is over here. It's actually, you can look at it. It's related to this K graph. Okay. So the whole set, the whole subset is iterated through the whole thing is 2 to the power 3. You find all the combination, and pick two is only one of the term. One of the combination, then we call it K-graph. Any questions so far? Any questions so far?
No.
No.
Please answer, okay? Otherwise, I don't think you are listening. Okay, then you have a lot of incomplete graph. That means it's not a complete graph. Okay, and then because you have 2 to the power 3, you have C3 peak 0 x 0 plus these differences. So there's only one term in here. C3 pick 2 is part of the complete graph. The rest of them, you actually may not pick all of them. We call it incomplete graph. Okay. So now let's look at how to generate this C2 pick, CN pick 2 problem. Let's assume we will have A, B, C, D, E. You want to pick any two of them and you want to generate the upper triangle. You don't need the lower triangle because it's reverse order. Okay, it's actually not alphabetical order. So reverse alphabetical order or alphabetical order, because it's combination, we don't care about the order, so you just need to pick one. Okay, so let's assume that we pick the top upper triangle. So upper triangle, you got this one, A, B, C, A, B, C. So this is 0, 1, 2, 0, 1, 2. So you iterate through your I from 0 to n minus 1, because n this one n minus 1 you don't need. So your I started from 0 and then I less than n minus 1. Okay, because I equals n minus 1, you don't pick it. The 2 you don't pick it. You actually do not need it for the upper triangle. Okay, so your J started from your I plus 1 and J less than n and J increase. This is where you generate this upper triangle part. Okay. So if you look at the graph, you have a window of 2 you can pick. You pick 2 numbers. So the first number you pick will be A, B, C, D, the first one, because you cannot pick the first one as E. E cannot be the first one. E be the first one, you don't have the second one. So your first one can only be A, B, C. Let's assume you pick A. Then your B, your second one can be B, C, D, E. You pick the first one as B, then your second one can be C, D, E. You pick the third one, C as the first one, then your second one can be D, E. You pick your first one as B, your second one can only be E. As you can see, this actually would generate a so-called upper triangle. Okay, so based on this idea, we know that how we generate CN pick 2. Okay, how we generate CN pick 2. So let's do it in the program. Okay, this one I think in the chapter 18 or something, we already did it. I just review it one more time. We have other things we will cover today, okay? But today we just try to create a version that we can use it, okay? Make sure you understand it when you need to generate all the combinations. So let's assume the set is a string, S equals, let's just consider ABC, okay? And then you will, okay, let's import java.util star. Okay, all the combination, we would like to use the array list to represent it, okay? So you get an S, you want to generate all the combination in different array list. So you create a set equals new array list of string. At the end, you will return this set. Okay, let's work out the main program. Okay, you actually just print out this combination of this string. So you put a string into there, you start to generate all of the combinations. So you do for integer I equals 0, I less than as the length -1, I increase. Okay, this one is actually go up to the n-1. Okay. And then your j starting from I plus 1, and then j less than as the length. Okay, and then j increase. And then you have set that add empty string plus as the captor at I plus as the captor at j. That's it. Okay. This one would generate all of the combination of your P2 problem. So here, let me put another 2 more. Okay. Any questions so far?
No.
Now, if the problem we modify into pick 3, we don't pick 2, we pick 3. Pick 3, then you have Cn pick 3. So the first one, you can have this one, right? You can pick this one. When you pick this one, the second one, you can go through here, 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 here. Any other one can be the second one. Now, if you pick the second one as this one, then your third one can be this one, or this one. Okay, so I equals 0. I less than n-2. I increase. Then j equals I plus 1, because you're starting from I plus 1. I is here, j equals I plus 1. But j less than n-1. You have one you cannot touch. Okay, because you have P3 now. J plus plus. Then you have k equals j plus 1. And then j less than n. K less than n, and then k increase. So that's the way you do pick 3. Okay, let's do pick 3. Let's copy. We don't want to waste time. We want to be quick. So here I will say combination 3. So this combination 3 right here, we just copy this thing. Put it over here, change this I, j to k. Okay, this one is k less than s the length. This one j need to -1 more. This one need to -1 more. That's it. And here we need to add one more curly brace. That's it. So this become a pick 3. And then we actually copy this thing, put it over here, change to combination 3. It will generate all of the 3 simple combinations. So in principle, you can generate any number combinations. I'm sorry, I missed one. Here you also need to have an aspect factor at k also need to be added. Now, once you're done, you go, you generate. How comes there's a BB? Something wrong? Let me check. Oh, I'm sorry. After you finish, you need to do set clear because the set may have been used. Let me see, let me check. Let me check. You have I plus j plus k. This one should be j plus 1. I'm sorry. Here is the j. This is the I equals 0. J equals I plus 1. K equals j plus 1. Okay. This combination 3 or 4 in the user code, it really happened before. Some problem do need it before. So this is combination of 3. So you can also generate combination of 4 or any number you want. Okay. Any questions so far?
No.
No.
Okay, now we finish the combination. Next one, we go through the permutation. So combination is, you don't care about the order, but permutation, you do. You do care about the order of the permutation. So let's assume that you do have A, B, C. Combination, you pick 2, you just pick A, B, A, C, B, C. So A, C, B, C, B, A, C, B, C, and B, A, B, C, C, A. Okay, this one is alphabetical order. This is reverse alphabetical order. Either set it can work because we don't care about the order. So one of them we call it a combination. Now in permutation is different. Permutation we do care about the order. So you have A, B, C, and then you have A, B, C, you have A, C, B, you have B, A, C, you have B, C, A, you have C, A, B, you have C, B, A. So totally, this we call it P3 pick 3. P3 pick 3 is equal to n band divided by n minus n band. So you'll be 3 band divided by 0 band, you'll be equal 6. Is that okay so far?
Yeah.
Harrison, are you okay?
Yeah.
Can you understand this one?
Yeah.
If you haven't learned this permutation number, then your math teacher should be in trouble. He doesn't teach you whatever you need in middle school, okay? This one, I believe that for me, I may learn this one in 7th grade or 6th grade. If you haven't learned this permutation, how to calculate the permutation number, then that means you are behind, okay? You have to pick up, Where to pick up this permutation number? Usually is in number theory, so you would go to ALPS number theory. I think they will give you the number theory, introduction to the number theory textbook, okay? They are different kind of numbers theory you can pick up. Okay, they do have something you can find permutation and factorial, okay. And there are problem in ALP and AMI problem that involving this permutation as well. Okay, so it's not just for AP user code, but also for AMI for mathematical competition. Okay, you have to pick up this. Okay, if you don't, you are in trouble. Okay, this is permutation. Now we want to look at permutation. Permutation, in a way, is also called anagram. Okay. So 0, 1, 2, 3, and 2, 0, 1, 3. These two we call it anagram. It is a string of different symbol, but they share the same number of the symbols. But it actually come out with different permutation way. This permutation, we want to generate every possible anagram in the same permutation. Okay. So this anagram, you need to study. Okay, you need to understand what's the anagram. By the way, we have some homework, but some of you are not really working on the homework. What's wrong with it? Hi, Jiang, are you still following the homework?
You mean the eco website?
Yeah,
Yeah.
you need to submit, okay? There is a problem on anagram. We have A, B, C, C, and then A, C, B, A, B, C. These two are anagram. So how you can check anagram? The two string had the same number of the string, 1A, 1B, 2C. For Jiang, how can we check these two strings are anagram?
I made a hash set and I made a hash set to store the number of characters found in the first string. And I looped through the second string and removed the characters from the hash set, and like if there's a leftover number or
You compare their hash set. Okay, that's
Yeah.
okay. How about Steven? You have other way to solve it?
Like their ASCII code.
This
Like-
what ASCII code.
Like they have different ASCII codes, and then you just check if they're overlapping or the same. And then if they're the same, you don't use that one.
Use what?
If
You
there's like
say look through the ASCII code. ASCII code doesn't give you whether it's an anagram or not.
not sure.
So we actually covered it before. Okay. So about the anagram, there are a few problems you need to know. Number one is you check two strings whether they are anagram or not. Okay, these two are anagram, right? But by verbal viewing, we know they are anagram, but we want to check it by looking at the. One way to do it is, I see Harrison's homework. He tried to use a delete. I saw it and I delete every character. You find the index of and you delete the index. That's okay, but the problem is deletion is very costly. You delete, you means that your array need to be rearranged. You need to move everything forward. Then that's the order n for single delete is the order n. And then you have So you actually, this one will be at least n squared algorithm. That's too much. Okay, that's too much. That's n squared algorithm. That's actually too much for anagram. So here you will actually return Boolean. Okay, check anagram to see if two string A and B they are anagram or not. These are supposed to be homework, so you should finish it before I talk about it. But too bad most of you did not finish the homework before. That's a problem. You get this too. So you do histogram A equals new integer 26, integer histogram B, okay. Delete is okay, but delete is not too costly. So you create two histogram. This one should be I. Okay, I'm sorry, I beat wrong. So this one is a constant time because it's actually 26. I'm sorry, it actually is n time. N time 2n. So this is 2n, 1n, 2n, the length of A. Okay. And then after you finish, you go to for integer I equals 0, I less than 26, or and then I increase. Okay. If HA of I not equals HB of I, the number of the element is not the same, you return false. Otherwise, you return true. So this one is an order n algorithm compared to your deletion. This one is way faster. Using histogram to check the answer. Okay. Okay. So this is to check the anagram, whether two string are anagram or not. Okay. We are in competitive programming. Not everyone need to go. If you don't like it, it's okay. You don't submit homework. I don't actually like before check every day to force you to submit homework, because if you don't like to go to user code, we cannot force you. It's an Olympic. You are not suitable, you just don't go. Okay. But if you want to go, you have to work on the problem set that we assign to you, especially the gateway training. It's not it's not really in our Moodle class. Okay, not in our Moodle shell, but you have to do it because you want to compete. Okay, if you don't want to compete, it's okay. Nobody care about you. Whether you go or not go, it's up to you. We don't actually force you to do it. Okay, it's your own option. But if you do want to do it, you have to follow us closely. Okay, so today we already started the ad hoc solution. We are moving on to the so-called complete solution. And we cover a few problems. Today we will cover this Friday the 13th, and we will keep looking into the different problem in the gateway. Okay, you have to follow. If you don't follow, you pretty much lost. Okay. And we don't care about whether you are lost or not. My job is to teach you or give you the guidance of where to go. But if you don't want to go, that's up to you. That's not my job to force you to do anything. Okay? Is that okay?
Yeah.
Okay, now we want to generate all the combinations. So to do all the combination, we will need to use a recursion. Recursion is the solution to find all the combinations. So now let's look at the problem. You want to generate all of the anagram. So the idea is that you want to do recursion. So that's assume you have the 0, 1, 2, 3, you want to do recursion. So let's look at if the first symbol is 0, then you permute through the 1, 2, 3 for the rest. So the first one is 0, you will get 0, 1, 2, 3, 0, 1, 3, 2, 0, 2, 3, 1, 0, 2, 1, 3, 0, 3, 1, 2, 0, 3, 2, 1. So this totally right here, 6 possible solutions, and always 0 as the leading letter. So what happened is that you use the leading letters, each one of them as the leading letters, and then you commute the rest of them and then hook them up together. You will get a solution. This is the idea, okay? This is the idea of generating all the permutations. Okay? Harrison, are you okay so far?
Yeah.
Now, we want to write a program to generate these different all possibility of the permutation. Let's do it, okay? Let's do it. So we want to do permutation through ABCD. Okay, it's a string. You would generate all of the possible permutation of this S. Now you have a function called create permutation. You will return as a array list as well. Okay, so import java.util.start. Okay, now you want to do permute, so let's do permute. So you permute over the string. Now, so you may have zero symbol, one symbol. That's actually what one symbol. Okay, we talk about it. That actually we have the A, B, C, D. That's just when that you actually keep A as the first symbol, and then you keep B as the first symbol, and then C, and then D. That's just when you keep starting with A, then you permute B, C, D. You permute C, B, D, you permute B as the second symbol, and then you permute C, D, and then you use a C as the first symbol, you permute D. So at the end, you will actually permute only on one symbol, and at the end, you no longer permute it, you will just return it. So when you ask the length equals 1 is the permutation condition, you will return you will actually create array list. I'm sorry, let's actually create array list right here. Okay, no matter which permutation you use, you always need that, okay? So right here, you would actually, you will do set that add. You put the S into the array list. That's a single, that's D. That's a single array list with single string. Okay, once you do that, you will just return the set. That's the permutation of the D character by itself. Okay, if you are down to single letter, then you directly return that string as an array list. Okay, if not, then you need to use all of the every single letters as the first letter. So let's do this one. Let's do for integer I equal 0, I less than x dot length. I increase. So let's assume that we have a set string head data. So the head data should be equal to double quote plus aspect character. You pick that data out, right? You pick that data out, then the isolator is your head, and you will continue to permute. So the array list of the string rest permute. The rest of the string will be permuted using the permute function. And this permute function will permute on a string. Which string you permute? You will actually cut character I out. So string rest will be equal to as the substring 0 to I, not including I, plus as the substring I plus 1. That's the rest of the string, and you put that into the permutation. Is that okay so far?
Yeah.
So once you get the permutation, let's see, you actually get the permutation. You get a permutation. Let's assume you have the A, B, C, D. Your first letter is A, you permute B, C, D. You permute B, C, D, you will get B, C, D, B, D, C, C, B, D, C, B, B, D, B, C, B, C, B back. You get this one back. And then you need to connect A to each one of them. Right? You need to get each one of them. So you get this array list permute. So you do for let's see, integer j equal 0, j less than rest permute that size j increase. You go through every single one of them. And then you actually do, you set that at what? At your head plus rest permute that get j You get one of them and then combine with the head, and then you put into your set. Each one of them you put into there, and then you combine. And once you are done, you return your set. Okay, this one cut your head out, permute the rest. Once you permute the rest, you get every single permutation from the rest, putting the head back to there, and then put into your set, and you return your set. Okay, then that's test set. Okay. This is peak 4, so you actually is 4 band. 4 band is 24. Okay, 24 of them. Any questions so far?
No.
Wait, I have a question.
Yes.
Right, can like the permutation be also made with like using the previous combination formula, but like for the for loops, instead of like having the nested loops start at like I plus something, have it start at 0, won't that also become a permutation one?
Which one you talk about again? One more time. I am not sure what you are trying to get at.
The combinations formula.
Combination. We are talking about permutation. You are talking about combination or permutation.
No, like is it possible to like change the combination like nested loops where it starts at to become like a permutation one?
You mean using the recursion?
No, without like recursion, like using the combinations formula as a base for their permutation formula, but like changing the combination nested loop like where it starts at.
No, because combination you only get the upper triangle or lower triangle. Here the order is different. So you use that loop or it won't work. Why are you thinking about it that way? Permutation and combination are different. Permutation, your A, B, and BA are considered to be different in permutation. This actually you have in combination A, B, and BA is considered to be the same.
Yeah, I mean like changing the combinations formula for like the nested loops part of the combinations formula
For what?
for like the starting index to be 0 instead of like I plus something.
Why you need to use I equals 0?
Won't that make it like a permutation?
That won't, because this permutation sometimes you would have this one, you change this one to 0.
Yeah, and like the third loop too.
This one you change to 0, you are working on this A versus ABC versus ABC. This is, you go the whole map, it's not combination.
Yeah.
So what are you talking about? This is
Won't
not
that
combination.
won't that make it permutation?
No, that's not permutation. This is actually A by B. This is actually ABC. You actually just do n squares. N squared is not PNP.
Oh,
It's actually a totally different problem. What are you talking about? This is not permutation. You change this one to 0, it's not combination. It's not permutation. Okay? It's not permutation. You have to know about the nature of the permutation and combination. Combination means that you actually just pick a 3 symbol or 2 symbol from a set, right? The order we don't care. So here you have the +1. This one creating the checking of the relationship. So if you start from 0, it actually doesn't generate all the combination permutation. It's nothing to do with the permutation. Permutation means you permute. You permute, actually, you go through the first one 0, and you permute the rest of them. First one 1, and then you permute the rest. This is not just A times B. It's not just this. It actually is the whole permutation. So when your degree go all bigger, it's not just 2D, it's multiple dimension. Not so simple. Okay? Any other question?
Wait, that code goes up on the website, right? The quiz website, like the one that, like your website.
Which one go to what my website?
The code that you just made, like I kind of want to review it after class, but
Oh, you mean the slice?
no, like the code that you just coded, like the permutative.
You mean this program?
Yeah, program that
Yeah, I'll
you.
send you, yeah.
Oh, it goes up.
Every week I'll send you.
Oh, okay, thank you.
Yeah, don't worry. Everything our class I'll send by email, right? If you don't get it, you can export it for the code, okay? Actually, I can send you right now. You can take a look if you're really interested, okay? I
Okay.
send you the permutation code at least. Combination, I think, is easy. You got to remember them, okay? The problem is not just, oh, I understand it. Understand is not enough, okay? Understand is not enough. You must be able to generate it by yourself, because later you are in competition. You have to code it right away. And you are not supposed to check the internet for the algorithm, okay? Even though another student right now may be cheating in the user code competition, but it's not allowed, okay? If you got found out for cheating in the user code, you probably in big trouble. So don't do that, okay? Don't do that. And then you have to remember all the algorithms. So this one, you have to remember them. Whatever we cover in class, you better check it by yourself, rewrite it by yourself. Make sure you really understand it. It's not just, I know it, you know it, that is not really not enough. You never remember the algorithm. You cannot use it when you need it, okay? There's one more algorithm related to the anagram. It's more advanced. I don't want to, we don't code it today, but you can look at it, okay? It's called the anagram in alphabetical order. So you can check this Geek website. They do have an algorithm that will generate the next possible anagram. Okay. What that means is that you have A, B, C, D. This is alphabetical order. So next one will be A, B, D, C. So you generate from this one to this one. That's called the next anagram. And you can put them into order if you need it. Okay. So the 24, you can permute to generate all of the possible permutation. That's one way you do it. The other way, you can go from the first one, sort it order, and then generate it one by one. That's another way you can generate all the anagram. Okay. For that one, it's actually more costly, but in user code competition, some year they do test on this generation of the next anagram, but it's in silver level. Okay, it's not in the bronze level. It's more advanced algorithm. Okay, here we don't touch it because we are not covering this. We are not covering the. You can generate all the anagram and do sorting. Okay, but that's actually take a lot of time. But there are some problem that would require the order. Okay, the order. Okay, anyway. There are internet, you can search for the answer. This one is not standard algorithm, so we don't cover it in class. Okay, you burn a lot of time, and then not everyone are interested. So we cover up to this permutation up to here. And then if you are interested, you can look at the permutation with order, okay? With alphabetical order. And there's also another permutation variant that's actually usually use PN. So you have 4 symbol ABCD, you permute ABCD. But it's also possible that you do PN pick 3. So ABCD, but you pick 3 of them for permutation. So you may end up with ABC, ACB, BAC, BCA, and then CAB, CBA. So these are all the permutation for ABC. And then you have this actually you miss out D, miss out A, miss out B, miss out C. So they are totally also 24 possible combination in P4, P3. Okay, there's a variant you can change for P4, P3. It's up to you. Okay, the way to do it is that when you do permutation, don't go down to this equals 1. So that's assume that you actually here you put another integer. So if you do Pn P3 right here, if the permutation down to 2, you should stop, not 1. Then you get Pn P3. Okay, there's a variant you can change for that. Is that okay? I don't exercise on that one as well. You will take time. You can put an integer as a limit to limit the number of depths. Here you will go down, keep permutation until you are single letter. But if you go down to if you just do A, B, C, D, you P or P3, then you down to 2 letter, you only permute them for the first letter, and then you don't go down to the last one. Okay, then you will get P4, P3. You can also do P4, P2. Okay, but that's not what we are covering right now. Okay, too much. But that's something you can study by yourself. Okay, is that okay so far?
Yeah.
We got to move. Okay, we got to move. Next one, we will go to the permute. Our goal is we give you the introduction of the whole competitive programming issue. So today we are on the search of the solution space. But as a search of solution space, I cannot cover everything for search of solution space. There are more things, and we need to move on. We have other topic we want to cover. Okay, at least we need to cover up to the level that you are good enough to pass the bronze level to silver. Okay, that's the goal that we have. So I cannot teach you super hard algorithm. Then that's too much. You don't need that for bronze. Okay. Next one, we do pairing. Okay, pairing is different issue than subset combination and the permutation. Pairing is another issue. Okay, let's look at the pairing problem. Pairing is actually more difficult than combination or permutation. So what is pairing? Pairing is that you have 6 people, okay, and they are dancing. This is people, maybe some girl, some boy, okay, anyway, any boy or girl. But you want to pair them into every 2 of them. So you may end up with A, B, C, D, E, F, A, B, C, E, D, F, A, B. So A pair with B. Okay, then there are 3 possible pairing. Is that okay so far?
Yeah.
And A pair with C, there are 3 possible pairing. A pair with D, there are 3 possible pairing. A pair with E, there are 3 possible pairing. So 6 people, how many pairing they can create when you dance with another person? So A, let's assume that A will pair with somebody else, right? So you have A can pair with B, C, D, E, F. So A can have 5 possible pair. So once A and another person, let's assume that you pair with B already. So A, B got kicked out. The next one is C. C would have 3 people to pair with. So C and D pick out. Then you have E. E would have only 1 person to pair with, that's F. So this totally 6 people, you will have N minus 1 times N minus 3 times N minus 5. Possible pairing. Is that okay so far? Number one, the total number of the people must be even. R cannot do. So let's assume that you have 8 people. You have A, B, C, D, E, F, G, H. Then the possible pairing you can create is A would have 7 people you can pick. So A, B, let's assume A, B pick out. Then you have C, C would have 5 people you can pick. So P, C, D got pick out. Then you have E, and E would have 3 people you can pick. Okay? And then E, F pick out. Then G would have 1 people H to pick up. So this one is N minus 1, N minus 3, N minus 5, N minus 7. Okay? That's the number of the total pairing that you can create using N number of the people. And this N number of people must be even. Any questions so far?
No.
No? Now, given that this is the pairing algorithm, every time you pick 1 person, so basically you go through A and pair with another person, and you return it, you pair with another person, you pair with another person, you will be able to do pairing, okay? So right here, you have the pair algorithm. You have let's assume that you have an array of integer. That's your partners. Okay, partners. So initially, we set every partner to be -1. You don't have partner. So partner 0 means A is a partner. So you have -1. 1 means B is a partner. You put -1. Everyone is -1. Okay. So let's see. You actually I equal 0. And then when you do pairing, you actually go through every alphabet. Okay, go to every alphabet. Alphabet is an array, okay? It's an array of strings. And then it's a partner partner, you would check if the partner is equal minus one or not. If it is not equal minus one, let's assume that you A pair with B, so A's partner would be one, and then B's partner would be zero. So these two actually pair already. So here, this one I means the unpaired people. How many unpaired people will be stored in I? Is that okay?
Yeah.
So if you actually I equals alpha by balance means what? Means what? Means you actually everyone are paired. Everyone are paired, then you actually print out your partners and you will return. Okay, so if everyone are paired, you print out all the partners. Okay, you print out all the partners and you will return. Okay, you will actually return. That means everybody are paired. You return. Okay, so this one, the partner array keep track of who is your partner. This one I think is just a print out the error, the temporary result. The key point is that you will store the partner in your partners. Okay. Now, if you lay out, so right here actually is all paired. If some part of them is not paired, then you will do the rest of them to pair the current one with the rest of them. Okay, you pair them, you pair the rest of them. And then once you are done, you return your current one and previous one. Okay? Any questions so far?
No.
No.
This one create all the pairs, okay? This one create all the pairs. And then you have the partners, you will need use the partner array to generate all of the alphabet. So you have another algorithm to use the partners and alphabet to create all of the possible pair that you want to have to create this pairing information. Okay. Okay, so that's the pairing algorithm. Once you are done, you will actually using the partner condition and alphabet, and then add that pairing result to the pairing array list. Okay, and your pairings eventually will store all the information here. Okay. Okay, so let's see. This is the pairing information. So let's go back to here. That's actually creating pairing. So right here, we are only calculating the index. We don't care about the so-called So initially we have this string A, B, C, D, E, F. These are the elements to be paired with. Okay, the partner array. We create the length of the S. Okay, and we have the pair algorithm to create the pair algorithm for the to create a pair algorithm. And this is void function. It doesn't return anything. It just assigns some value to it. Okay. So let's see that actually do pairing, and then okay, here let me change this in I to count. Okay, I is the counting the number of the instead of using I sometimes confusing for index. Okay, so here I change it to count. That means the number of the paired people. Okay, so here let's do while count less than partners. Let me see. Let's see. It's actually alphabet balance. Let's do. Okay, let's call this one alphabet. Okay. Be consistent. Okay. You keep increasing it. Let's see. Your I equals 0. And you go through to find a I. Okay, I'm sorry. This one should still be I. Okay, that's counter is not good. Let's use I because I will stop at 1 that's actually that's unoccupied. Okay, I will stop at 1 that is unoccupied. So you basically go through A, B, C, D, E, F, and you look at who is not paired, who is not paired, who is not. So you stop at the first one. I will stop at the first one that's not paired. Okay. So if you were I equals alphabet balance, that means you finish it. Okay, you return. So right here, this one is to generate the pairing condition. But right here, we do not bring out the pairing condition. Let's do bring out arrays like two string or partners. Okay, later we will use the partner to generate the pairing condition. So here, each one of them would have the pairing index. So if I equal alphabet length, that means that you 0, 1, 2, 3, 4, 5, you may have 1, 0, 3, 2, 5, 4, and that is one pairing assignment. And you based on that pairing assignment to print out your pairing. Okay, so right here, but right here we do not use it. Okay, we do not use it. So now we get that done, and then okay, then we got I. So I is the first unpaired person. Okay. Then we would do for integer j equals 0, j less than alphabet balance, j increase. We go through every single one. So you got I is unpaired, and you go to every single one of them. J actually start from I plus one, so it's the next one, okay? It's from I plus one. And then if partner of the J actually is equal to minus one, so it's unpaired. If this one is unpaired, then we will pair it. Okay, we will pair it. So this I will stop at a certain I that actually partner is equal minus one. So here I is minus one, J is also minus one, okay? Then you would have your partner of your I will pair with J, so pair with J, and partners of J will be equals I. Okay, these two, you pair them together. These two, you will pair them together, and then you will continue to pair the rest of them. Okay, and then once you pair the rest of them, because you pair A, B, and you still need to pair B, C, D, E, F. So this one is to pair C, D, E, F. Okay, and then once you pair them, you actually return your pairing condition. So your I put back to minus one, put them to unpaired condition. That's it, okay? So here, public static, let's run this pairing first. So here we just do pair of the alphabet, okay? Oh, I'm sorry. We do have this pairing, we need to clear it first, so. We need to set it, everyone to be minus one, to clean up, so no one actually got paired. Okay, then let's see. Stack overflow. Stack overflow, let me see, something wrong. We do have this pairing condition. And once it's done, How come it actually doesn't generate the rest of them? We have this pairing, and then we return, would return it will return, you return, actually right here, you return. Once it's returned, the partner return. Oh, I'm sorry. This one is over here. Is when you do when you have an empty spot, you pair them together and then go into pairing and then return. Okay, sorry, make a mistake right there. Okay, so these are all of the possible pairing are here. Okay, now next one is to generate a pairing and then put them into the array list. Okay, and then put them into the array list. So let's create an array list. Let's see. Okay, now here we have a partners, and then we would like to create a pairing string. Okay, so each one of them, let's assume that you have 0, 1, 2, 3, 4, 5. You do have alphabet of A, B, C, D, E, F. Okay, and then this one is 1, 0, 3, 2, 5, 4. So this one, you will generate these two together, right? You will actually create AB. Okay. And then this one will create these two CD. Okay. This one will create EF. Okay. So that's actually we will use that pairing condition to create a AB CD-EF pairing condition based on this array. Okay. So that's the goal. But I'm not going to use the same algorithm I'm using right here. I'll use a different way, okay? Give you the for comparison. Right here, we do have a pairing algorithm right here. This pairing algorithm, I'm sorry, this actually is actually giving you the partners and alphabet, and then you will do hash map. So right here, this one recursively generating the hash map. So you have the hash map of the integer. This one. This one is actually using the recursive, let's see, actually using for loop. And it creates partners and then add it to the text, okay? Okay, that's actually, I'll simplify this one anyway, okay? Let's still call it generate. But I'm going to write it in different ways, still using the hash map, okay? I'm going to use hash map instead of using hash set. So right here, that's actually create public static, okay. Here we will generate a string, okay, and this one is actually called generate. Given me the integer array partner, and give me the string called alphabet, okay. Now, the alphabet is a string, but we would like to create a reverse string for it. So let's do map of the string and integer. N equals new hash map. Okay, so you have this A, B, C, D, E, F, and we would like to generate a for index 0. Let me see. Is that necessary? No. I'm sorry. This one probably not. We don't need that. Okay, we don't need this map. We don't need to make this too complicated. So you have the partners. You have the A, B, C, D. So you would need to have a. Okay, let's still use a set. Okay, let's use a set. So this set would be the one that been picked, the one that already been picked for print now. Okay, for print now. So let's do set x equals has a set of the integer. Okay, this set is here I'm missing new. Okay, so this set will be putting into the numbers that already have the partners. So here we will do this. Okay, we will do for integer I equals 0, I less than alphabet the length. You go through every single one. I increase. Okay. Now you go through the first one. So you will do this. You actually do. You will okay. If S that contains I, okay. That means I already been used. Okay. That means I already been used. So that's actually assume that it's actually not including I. Okay. So I is not picked yet. I is not picked yet. Then you will create a string. Okay. String actually let's do this one called P. Okay. String P. String P would be equal to empty string plus alphabet of I. Okay, alphabet at the vector at I plus alphabet that vector at partner of I. Okay, so you do have these two, and then you will set that at your I set that add your partner's I, okay? So these two you got added to the set, okay? So this one means that if you don't contain the I, that means that this this I had not been prepared for the pair, then you create this one, okay? That one, and then okay, and then you need to take care of the whether you have the you want to do this, you want to do A B dash C D dash E F. So the first one you actually do A B. Okay, the rest of that will be dash something. Okay, this is actually similar to print now. So let's do this. Okay, let's do here. So here we should have a string called R equals empty string, okay? So if the first, then we will do this, we'll do R plus equals P, okay, and then first equal false, else R plus equals dash plus P, okay, and then we don't need anything else. And at the end, I'm sorry. At the end, you will return the string. Return the string R. Okay, so this one generated an alphabet using the string is okay. Let's actually use this one. So right here, we substitute this part. Okay, and you generate a string. So you would do right here, you would do system.out.print line. Okay, of the string. So you would do generate of your partners and your alphabet. Using the alphabet and partner to generate, okay? Okay? That actually all the pairing condition. Is that okay so far?
Yeah.
The pairing condition, I use a string, but if you want to use let's see, if you want to use a pair, if you want to use a pair plus, that's okay. Right here, I'm using a string, okay? I'm using a string for pairing. So this is a pairing condition right here. This one is arguable, okay? The print out format is arguable. Whether you want to print out or you want to put that into an array list, that's up to you. But right here, we just print it out. Here we can use a array list of the string to collect all the pairing into an array list. Okay, that's also possible. But we kind of don't do it this way. Okay, so here we keep calculating the indexing using the pair algorithm and then using the generate algorithm to generate the possible pairing print now. Okay, these are what we covered today for pairing. So this end our talk today for the complete search. Okay, so complete search, we do cover subset, combination, permutation, anagram, pairing, these different things. Okay. I don't think today we have time to cover the Friday the 13th, but I will do it next time. Okay. Any questions so far?
No.
No.
And then keep working on the problem. Keep 3 problem a week. Okay, 3 problem a week on the user code training side. So here user code training side gateway. You follow our slides and the problem, okay? And then you need to go to the user code pass exam side to work out 3 problem a week, okay? In addition to the homework. Because if you just work on the training side, it's not enough. You don't see every kind of a problem. You don't get enough experience when you go to the competition, okay? This week, we do have a competition. You want to join is okay. Get 0 point is okay. We don't care, okay? At this moment, participation is good. Whether you pass it or not pass it is not important. We need you to work on more problem, making sure you knowing about the process, okay? And some problem like, okay, I cannot read the file. Those kind of problem, you need to fix it by yourself because you are in competition. In the competition, nobody will tell you, oh, you missed this A.in, you actually did not include it. Or you actually, the input format is wrong. You have to figure it out, okay? Is that okay? Is that okay?
Yeah.
You have to figure it out. We cannot help you, like babysit you in a competition, okay? That's your own job. So file not found, format wrong, test pattern wrong, you have to figure it out. You have to fix it by yourself. Right here, we can only teach you how to solve the problem, make you more efficient in coding, okay? Those things that we can improve it, coaching you to do it. As long as how to fix the problem in the competition, you have to figure it out yourself, okay? Because nobody can help you. If we help you, we are in trouble, okay? We're in trouble, okay? Okay, keep working hard, okay? And then February 28th, we'll start a review for APCSA, okay? At that time, you will have a lot of homework to do as well, but that's more for the exam. Okay, and this user code part, we will keep doing it. Maybe we will finish it before February. Maybe we need more time. If you will need more time, I'll let you know, okay? I'll let you know. Okay, and then starting from June, if you're still interested, in June, we will start to do CC double plus. Okay, we'll teach you CC double plus. CC double plus is more complicated than Java. And then we'll teach you CC double plus because there are some more advanced competition and AI will need CC double plus. So let me know if you are interested to continue in June. Okay, it's the same similar that we will get started in summer because the whole CC double plus will take 1 year to finish. Okay, and then if you want to do goal division, you will need that. Okay, you need that. Okay, that's what we have so far. Good night and bye bye.
Thank you.
Bye. Thank you.
Bye bye.